Alright, buckle in, time for a long FRQ. This is the second one from the AP Chemistry exam in 2018. And yeah, part 1 says that we need to draw the reactant particles of this reaction. Okay, so first of all, you would count the number of the number of products on the product side. So we have 4 NO, and we also have 4 NO2s. And then you would look at the reaction on the top. It's already balanced. And then determine the stoichiometric ratios. Like, for example, you have 4 particles of NO that's still unreacted, and you have 4 moles of NO2 that's produced, which means that 2 moles of reaction happened, if that makes sense, because in one reaction you make 2 moles and then you have 4, so that means 2 moles of reaction happened. So you would double the reactants, and also you would add the additional 4 NO that was unreacted. Alright, so you end up with 8 NOs and 2 O2s. And then for this next part, it says to find the equilibrium constant, so we would use the delta G value here, because you're not given any partial pressure, so that doesn't really work. But anyways, you write the equation out, delta G equals negative RTL in K. And then you plug the values in. So 870 joules minus, this is the gas constant, times the temperature, which is given, and the natural log of K, which is what we're trying to find. So, yeah, you would do e to the power of 870 minus the r times t part, negative, equals K. And for my answer here, I got, here, 0.7038. And then you probably don't have to round, but it's always safer to. So 0.70 is the number of sig figs we were given. Alright, now for the next part. So it says that if both the partial pressures of the reactants are initially 1, will the partial pressure of the reactants at equilibrium be equal to 1? Justify your answer. Okay, so what we have to recognize here is that if we look at the P that we found from the previous part, we would see that, let's see what it is. K is 0.703. So K is not a very big number. Oh, look at me underline that. Okay. K is not a very big number. What am I doing? Okay. K is not a big number. So that means that at equilibrium, there's going to be more reactants left over, because that's just the K is the ratio of products over reactants, right? At equilibrium. So if you have a K that's less than 1, we can pretty much know that there will not be as much products as there are reactants. So there's more reactants than products, which means that at equilibrium, the partial pressure of the products should not be equal to that of the reactants, because the reaction doesn't go to a point that makes it so that there's more reactants than products. Okay, so for the next part, this is about a student hypothesizing how changing the temperature will affect equilibrium. I don't know what happened with that line there. I think that was an accident. And then, so, okay, for this one, we would look at the delta H value. Since heat is a product, increasing it would shift the equilibrium left, which means a decrease in the amount of products. So you would say disagree, because it wouldn't increase the amount of N2O3, but actually decrease it. Alright, so for the next section, part D asks us to complete the Lewis dot diagram, and also it tells us to include the lone pairs of electrons. So what you would do is you would like get the number of valence electrons that these elements have. So H is 1, O is 6, and N is 5. Then you just have to kind of piece them together. So like combine them so that they all have octets, all have 8 electrons around them, the elements. And then yeah, just arrange them so that they have different bonds, and be sure that you end up showing the lone pairs. Like for this one, nitrogen would have a lone pair on the top, and it has a double bond to the oxygen on its right, and it would have a single bond to the oxygen on its left, while the oxygen would just have one bond to the H on the left. So yeah, H's always have one, so it can really only make single bonds, so there's that. Or you can draw it with like lines to represent bonds instead of instead of dots for bonds. And then yeah, just be sure to always include the lone pairs. For the next one, hybridization. Okay, so the hybridization, it would be sp2 because it has 3 electron domains, like 1 going up and 2 going to either side of the nitrogen. Next section is about titration. For this one, we have a titration curve. Part 1 says to determine the initial concentration of the acids, we're going to start with the equivalence point and finding the volume of base there is 20 ml of potassium hydroxide. So we can find the moles of the base and set it equal to the moles of acid to find the initial concentration, because at the equivalence point, the moles of base equals moles of acid. So we can just use the molarity equals moles over liters to find the moles of base we have at this point on the titration curve. Okay, so plug the numbers in. We get 0.002 moles of potassium hydroxide added at the equivalence point, which means the same number of moles of acid at this point in the titration. So now what you would do is look for the volume of acid, which is 100 ml, and then do the molarity again, 0.02 over 0.1 equals 0.02 molar nitrous acid. And then next part is estimate the pK. So since this is a weak acid, pH equals pK at the half equivalence point, and the half equivalence point is halfway between the equivalence point and the initial starting point. So it's at 10 ml, and it looks to be about a little more than 3. So for this question, they would definitely be pretty lenient on what you put as your answer. So my eyesight is kind of bad, but that looks like about 3.3-ish maybe. Alright, so that's what I'm going to write, 3.3. pH. PK. Yeah, PK. Yeah. Close enough, honestly. Probably take like between 3.2 and 3.5. I don't know. During the titration, it's been added which species at higher concentration. Okay, so we know that at the half equivalence point, the acid equals the concentration of acid equals the concentration of the conjugate base. So since this is beyond the half equivalence point, we would have more conjugate base here, because more of the acid would have been neutralized by the base. So yeah. Okay, I'll just write that down. The conjugate base is present at higher concentrations. Because 15 mils is past the half equivalence point. And yeah, that's the FRQ. Have fun studying and good luck on the AP exam.